Okay, now let's start with the next module, which is Administer Azure Networking. In this module, we are going to focus on configuring virtual networks in Azure. We'll also focus on things like network security group, which will help me to make my virtual network secure by configuring inbound and outbound security rules. And then we're also going to talk about hosting our own domain using Azure DNS. And obviously, after this, we have one lab associated with this module. So let's get started. Let's start with configuring virtual networks. Obviously, when you're dealing with virtual networks, the first thing you have to do is you have to plan virtual network, because when you create a virtual network, it's ultimately going to be configuration with your private IP address range, with how many subnets you want, what kind of a configuration you want with that. So we have to focus on virtual network, subnet creation, planning for the private and public IP addresses, integrations with that, and then we also have to focus on creating and associating public IP addresses. We'll focus on allocating or assigning private IP addresses, and at the end of this, obviously, we're going to see how we can create virtual network with one or more subnets and the IP address range. Let's start about planning a virtual network. So basically, Azure Virtual Network is a service that provides the fundamental building block for your private network in Azure. You can think like this is your own private network only, but the only difference is this is available on the Azure cloud. A virtual network is very similar to your traditional network on-premise. But the only difference is you're not going to operate this thing in your own data center. Instead of that, this is on cloud. It also brings some extra benefits of Azure infrastructure, such as scaling, availability, and isolation. When you're dealing with this thing, remember, your Azure Virtual Network can always allow you to connect with your on-premise network or some other networks with that. You can connect one network with other networks, and that is something which is possible with multiple ways. We have a separate dedicated module in which we are going to talk about virtual network connectivities, so let's not talk about that right now. Right now, we have to make sure that when we design a virtual network, we are going to focus on creating dedicated private cloud only kind of a virtual networks with a specific configuration where we make sure that the environment which we are configuring with virtual network is secure. As you can see in this image, you're mostly going to have one virtual network inside which you're going to have subnets, which can be minimum one or multiple can be there. And each subnet can have multiple virtual appliances inside that, like virtual machines. Every virtual machine can also have a specific network interface card or some other kind of a configurations with that, using which it can associate with your private or public IP addresses. This slide is actually showing you how you can actually create a virtual network. You have to just provide a basic configuration like which subscription, which resource group, and what kind of a virtual network name you want to give. But after that, you have to be very careful about providing a proper IP address configuration, because IP address configuration of virtual network is going to be useful when you are going to connect this virtual network with other virtual networks. So you have to define a proper address space and at least one subnet, which is going to be a default subnet of your virtual network. When you're dealing with this, also make sure that you are going to take care of overlapping addresses spaces when you're configuring virtual network. Because remember, any point of time, you are not able to connect a virtual network with another virtual network which has overlapping IP address range. Obviously, we are talking about private IP addresses. So make sure when you try to do virtual network connectivity, you focus on IP address space and the configuration of virtual network. As you can see here, this screenshot is showing you that we have one particular network with multiple subnets inside that. We have subnet 0, 1, 2, which are actually belongs to a particular IP address range. I think each one is having /24 subnet mask with that, which is showing me that total we can have 256 IP addresses in that. Just for your kind information, 5 IP addresses will be reserved by Azure. So out of 256, 251 IP addresses will be used by you. Some of the networks are showing you that the available IP addresses in that is less than 251 because maybe we have already deployed some virtual machines inside those networks. You also have 2 networks, which are one created for Bastion as well as another one which is created for Gateway, which is maybe we are going to use when we want to provision virtual private network gateways with that. Now, obviously, there are different kind of possibility and configurations can be there with the IP address range and the subnet mask. Remember, subnets are always going to help you to improve security, increase performance, and make it more easier to manage your network. Because once you create a subnets, after that, you will be able to associate them with the network security groups. Each subnet must have a unique address range and it cannot be overlapped with other subnets in the virtual network in the subscription. If you try to do that thing, it won't allow you to pass the validations of the subnet creation. Now let's talk about IP addresses a little bit in depth. I'm sure you all are aware with this that we have public and private IP addresses. Public IP addresses are going to be used whenever you have some internet facing applications. So best practice is this, that maybe you're going to use public IP addresses for your load balancers or public facing services which are directly accessible on internet. While maybe you're going to use private IP addresses for your virtual network, on-premise networks, VPN gateways, or express route, where you are focusing on more security related things. Also remember, we can have a dynamic and statically assigned IP addresses also, and we can take care of the configuration on what kind of an IP address assignment we want to do with that. This screenshot is showing you that how you can actually create a public IP address. You can provide a name, you can provide an IP version, whether you want to go with IPv4 or v6, and then you can choose whether you want that IP address will be dynamic or static. Also, there is one last option in which you can choose whether you want to go with Microsoft versus internet routing. Remember, if you use Microsoft, it is going to be using a Microsoft backbone network, and it's not going to use any particular public IP address which is associated with internet facing. Now, obviously, all these configurations are making each IP address different, and then you have to decide wisely which one is going to be the perfect for your requirement. This slide is showing you a public IP address configurations. Like when you are going to use public IP addresses, whether you're going to do IP address associations will be dynamic or static. As you can see here, for virtual machines and load balancers, we can configure IP address association with network interface card or the front-end configuration in which we can use dynamic or static both. While on the other hand, when we focus on VPN gateways or application gateway kind of things, most of the time we can have a dynamic kind of IP address configuration, but sometimes we can have static kind of IP addresses also. Remember, a static IP address is only available on certain SKUs, and that's the reason this star is actually available there. You cannot get this thing on all the VPN gateways, especially VPN GW, which is starting with basic and all, is actually not having those features. When you're dealing with public IP address, the resources can be associated with the virtual machines and network interface or internet facing load balancers or VPN gateways and application gateways. In our case, when we are going to do the lab, we are going to create a couple of load balancers, virtual machines, application gateway kind of services, and then all that time we are going to use public IP addresses. Same for the private IP addresses. When you check here, most of the time when you're dealing with private IP addresses, it can be associated with your virtual machines, internal load balancers, or application gateways. Remember, as these are private, it's going to be not available on the internet publicly. You can keep them dynamic or static. A dynamic configuration is like Azure assigns the next available unassigned or unreserved IP address in the subnet's address range automatically. And when you want static, you can select and assign an unassigned or unreserved IP address in your subnet's address range. So basically you take care of that thing, or you want Microsoft to take care of that thing using Azure. That is something which you can decide. Hey guys, sorry for interruption. My name is Maruti and I'm here to make a very important announcement. I hope you are liking our videos and you're doing a continuous learning with us on an Azure cloud and AI related topics. If you are enjoying this thing, I'm going to announce skilltech.club, which is our upcoming website, which is going to be launched very soon. We are here to tell you one thing, that everyone who is a subscriber of this particular channel will get Azure Cloud and Azure AI related certification courses free of cost in skilltech.club. So you will be a part of the skilltech.club kind of a membership automatically free of cost. And everyone who's a subscriber of this particular channel will get those benefits which are available in that. So what are you waiting for? I request you to please subscribe to this channel and share it with your friends and families if they are also interested in Azure Cloud and AI learning. That's it from my side. Now you can carry on with your learning. Thank you. Now let's talk about network security group. If someone asks me what is a network security group, I always say this thing, that network security group is a very tiny kind of a firewall kind of a thing. So basically it's going to have some kind of an inbound, outbound security rules inside that. When you're using network security group, you have to understand how you can implement NSG. You have to define NSG rules, like as I said, inbound and outbound rules. And sometimes if rules are overlapping, you have to find out which are the effective rules associated with that. Then you have to understand how you can implement application security group also, and that's what we are going to see in this module. Let's start with NSG. Now, NSG is going to help you to simplify management of security rules. It is recommended that you always associate a network with the security group to individual subnets rather than individual network interface card with the subnet, because when you associate with the subnets, it's going to be easier to manage and administrative overhead is going to be much less. As you can see on the screen right now, this is a network security group which is created, and inside that it's actually showing you that it's going to be created in location East US. It has 1 inbound and 0 outbound configuration rules which they have configured inside that. NSG is basically going to list the security rules that allows or deny inbound or outbound network traffic inside that. It's associated to a subnet or a network interface card, and it can be associated multiple times. Remember, one NSG can be associated with multiple subnets if you want, but reverse is not true. This screenshot is showing you the inbound and outbound security rules which are configured inside this. Most of the time, these are the default rules which are always available. Just one thing which I want you to notice is, with every rule, you have a particular column which is known as priority. In this case, the priority which is having a lower number is the highest priority. So basically, in all these inbound rules, the rule with the 100 priority is the one which is highest priority, and the higher the number, the lower the priority. So basically 65,501 is the one which is actually your highest priority rule associated with that. Now obviously, when you're dealing with this, you can configure inbound and outbound security rules with different kind of a port and protocol configuration, with whatever actions you want to configure for that, whether you want to allow that or you want to deny that. Remember, when you have two rules for the same kind of a port number and the protocol configuration, the highest priority rule is going to override the lower priority rule. Also, you have to take care of one thing which is known as NSG effective rules. Now, NSGs are evaluated independently for the subnet and network interface card. So when you have a rule to allow or deny certain things, when you specify an allow rule, it must exist at both the levels for the traffic to be admitted. There are chances that maybe at the subnet level you have given allow rule, but at the NIC level you are not giving that thing. In that case, it will not be allowing you to reach out to that particular point. So this effective rules is basically trying to focus on two different boundaries. You have to focus on the access of network interface card as well as the access of the network security group also. And using effective rules, you can actually link if you're not sure which security rules is being applied on a specific requirement. This screenshot is actually showing you how we can create a new NSG rule for an inbound security rule. You can see right now we have 4 important properties in this. Source, which can be an IP address or maybe a service tag or maybe your specific IP address associated with that. Destination, which is also can be anything or IP address or a service tag or an application security group kind of thing. So you can choose which source, which destination you want. Then you can specify services, which is going to decide which protocol you want to associate with that. And at the end, you have priorities. Remember, lower the number, higher the priority. And the highest one is 100. Next, let's talk about application security group. Application security group enables you to configure network security as a natural extension of your application structure. It allows you to group virtual machines and define virtual network security policies based on those groups. Basically, as you can see in this slide, we have an application security group which is creating some kind of a boundary associated with your application server. You can see in this image right now, the outermost shield which is visible here is actually your network security group. But then inside this, you actually have 2 different application security groups which are configured. Now in this case, your application security groups are just nothing but logical grouped virtual machines. So maybe you have one virtual machine which is for web servers and another virtual machines are actually for application layer servers. And when you want them to connect with each other or communicate with each other, you want to make sure that the security is going to be taken care by application security group. Most of the time when you use this kind of application security groups, it's going to be wrapped with the help of NSG for added level of security. So basically you're giving 2 layers of security, NSG from the network level security and ASG for the application level security. Both will be taken care in this case. After this, let's start with our next module, which is host your domain on Azure DNS. If you have ever configured any application domain or some kind of a something.com kind of a domain name, you know that thing that DNS is a very important part when you do not want to remember multiple IP addresses or configurations like that. So what is Azure DNS is what we are going to understand first. After that, we'll see that how we can configure Azure DNS to host our own domain if you have purchased or if you have configured that. We are going to focus on verifying delegation of a domain name services. We'll dynamically resolve resource name using alias records, and we'll configure a private DNS zone. We have one lab associated with this, so that's also something which we are going to see practically. What is Azure DNS? Well, basically the domain name system, which is basically known as DNS, is responsible for translating, or I can say resolving, a service name to an IP address. Azure DNS is going to provide DNS hosting, resolution, and load balancing for your applications using Microsoft Azure infrastructure. Basically, most of the time when you create a new tenant, is going to associate with the new domain. And obviously, we are not able to remember or recall tenant ID, but we can at least remember the domain name. The domain name which is initially associated with your Azure DNS is going to be something.onmicrosoft.com. And then you can also add a custom domain name if you have purchased one. After the custom domain name is added, it must be verified. This is going to show you that whether you are an owner of that domain or not, and then you have to verify that process. Once you're done with this, your custom domain can be associated with your DNS. A DNS zone is going to be configured in that case, and DNS zone is nothing but a place or a host where you're going to have all the DNS records for a particular domain. If you want to start hosting your domain in Azure DNS, you need to create a DNS zone first for this domain name. And if you do not have your own domain name to create a DNS zone, then you can actually purchase it, or maybe you need to own the domain and configure this thing later on. Now, when you have multiple zones which are going to share the same name, each instance is going to be assigned with a different name and server addresses associated with that. You're always going to have root or parent domain which is registered, and then you're going to have a registrar and pointing to the Azure name server with that. Next, we have to focus on verifying delegation of a domain name services. So when you're delegating a domain to Azure DNS, you must use the name server names to provide an Azure DNS for all. Now, once the DNS zone is created, you should update the parent register, and for child zones, you should register the name server record in the parent domain. Now, this is not a very new thing. It's something which is a common process whenever you want to take care of the name servers. As you can see in this particular screenshot, you have a domain which is Azure AD mininc.org, something like that. And right side, you can see you have name server 1, 2, 3, 4. These name servers are the one which we have to manage. Once all these things are done, the last thing which you have to configure is you have to resolve resource name by using alias records. Now you can see here, we can add a record set, which is nothing but a collection of records in the zone that you have same name and it has the same type. You can add up to 20 records in the record set. A record set cannot contain two identical records associated with that. And that's why you can see right now in this example, we are having a type A kind of a record set, which is associated with TTL of 1 hour. And when you're changing this, you can actually change the drop-down type and can change to the information which is required associated with that. So when you go to this type drop-down, you're going to have different configurations like A, TXT, or something like that. And based on those record sets, you'll be able to configure dynamic resolve of the resource name. Last but not the least, we have configuring a private DNS zone. We all know this thing that a DNS zone is used to host a DNS record for a particular domain. Public DNS zones have unique names and are visible on the internet. However, a private DNS zone must only be unique within the resource group, and the DNS record are not visible on the internet, which brings to another additional layer of security. That's why you have to create a private DNS zone. In order to do that thing, you can see right now it's showing you a 3-step process. You have a virtual network called My Virtual Network, inside which you have a virtual machines. The first option is using Azure DNS, you are requesting for a private contoso.com kind of a DNS. Now, when you're doing this thing, the virtual machine is going to check for that. Now, because it's a private DNS zone, based on that, it's going to respond to the private IP address range. It's going to provide a name resolution for the virtual machines within that virtual network and between virtual networks actually. It's going to automatically configure the host name record management. It's going to remove the need for custom DNS resolution also. and is going to use all the common DNS record types available in all Azure regions as well. Basically, this is going to give you all the advantages of public DNS zone, but it's not going to be exposed publicly, so it's going to be taken care privately inside your virtual network. And as we have mentioned, it is going to be allowing you to associate with the between virtual network connections also. Now, obviously, all these concepts are very important, but you won't be clear until unless we see this thing practically in the lab. So I request you to just go to the next video and let's see that how we can take care of virtual networks and all these topics practically. I'll see you after this lab.